Hey, this is Steven from the Green Engineers, and welcome to my video on tips and tricks for extruding with the Multistruder for my Kickstarter backers. So today we are going to be talking about extruding filament with the standard nozzle, with the non-aggressive nozzle. One second. So what we're going to do, I had to get some knots out of the machine right now because of the digital amplifier on here. The new models use the analog. Analog is not susceptible to interference. So I had to extrude, and I had to extrude to where till I was getting good stuff. So once you get your unit out of the box, what you're going to do is you're going to assemble it according to my assembly video, which I will have up on my YouTube. And then you're going to plug it in and you're ready to extrude. So I would suggest that you have some sort of table or something. We'll see how it goes. I've only used a table, so I don't know how well the extruding all the way down the ground from a wall, because you have two ways of mounting, either bolting the back into a wall or bolting it into the floor, like bolting it into a table or clamping it down on a table, blah blah. So once you get your unit, you're going to turn it on. When you turn it on, you're going to get something like this. But the EXT, the extruder, is going to be off. I turned it on in this case to get it to start extruding. And then the HTR is the heater, and then at the top is the DT, DC, diameter target, diameter current. That's for automatic mode, which is currently not supported in version number 1, the stable version here. Okay. So then if you hit that little configure button, which is that little yellow one at the bottom, and also you see those TC flickering, that's because of the digital amplifier. It gets interference, something interferes the curve, and it basically flips around like that. So you have DT, DC again, diameter target, diameter current. You change the diameter current, which is what you're going to do by hitting these arrows up and down, these two arrows. I don't know if you can see that. So, and then the TC will approach, and then after you get the TC working, you're going to let it sit there for approximately 10 minutes for the heat to distribute down the heater pipe, the extrusion nipple or whatever, and then also to heat up the nozzle here. And I notice now, looking at it, that I'm getting hot there at the bottom, so dropping heat down. And then to fill up, unfortunately it's running, so it's going to be hard to see, which it's really hard to see now. But basically what you're going to do when you fill it up is you're going to fill it up to the point where I could kind of show you at the end of the video, but you're going to fill it up to where it is at the bottom of the auger, which I have already used quite a bit. So let me go ahead and get it to that point so I can show you guys. It's going through a lot of pellets right now. Okay. So, before you start extruding, of course, you're going to fill it up. And you see there, you're going to fill it up right to that tapering of the auger. If you fill it up any higher than that, you might have problems with it, starting to bog the motor down. But right at the top of the auger, where it starts to taper into the shaft there. Right as it starts to taper to the shaft, taper down, stop right there. So just fill it up to that base plate. And also, if you want to, you could fill it right up to that 2-inch nipple where the 2-inch nipple stops, and then it goes to the coupler. That way, if you ever want to take the motor coupler off, you can take the motor coupler off without having to empty out the hopper. Alright, so then after you waited 10 minutes and you're ready to go, my usual technique is you take a piece of extrusion that you already have. Sorry, I'm dropping the temperature real quick. Take a piece of extrusion and then press it to the side of your cap. And when you press it to the side of your cap, you'll notice that it will start to deform very quickly as you press it in. It'll start to kind of mushroom at the head. And you want it to be mushrooming very quickly. That tells you that you're at the right extrusion temp. Then go ahead and go back to the main screen when you're ready to extrude. Go ahead and go back to the main screen here, and then you're gonna just turn your extruder. So let me turn it off. So now it's off. Now it's on. Now, if you turn your extruder on, also another thing, the temp that I suggest is 240, and the reason being is that I always usually pick something about 10 degrees. I pick something about 10 degrees over what I would extrude it. So I extrude. This is 4043. This is 4043D, NatureWorks resin, and I usually 3D print it at about 10 degrees above regular PLA. So sometimes with Hatchbox I use like 200, but with NatureWorks I use anywhere between 225 and 230. So I'm going to extrude with about 240 Celsius. So after 10 minutes, you go ahead and start the motor, and if the motor immediately bogs and locks up, turn it off as quickly as possible. Go into the controller and turn the extruder off. That's all you have to do. You don't have to unplug it, just turn the extruder off. Then bump up your temperature about 2 degrees, and then wait 3 minutes, 3 to 4 minutes, then turn it back on. If the motor locks up again, so if the motor locks up, the extrusion's too cold. That's just, there's no ifs, ands, or buts about that. So you turn it on, you turn it up, turn the temperature up 2 degrees, wait 3 minutes, then start it again. If the motor locks up again, turn it up another 2 degrees, wait 3 minutes, turn it on again. And then keep doing that until you get extrusion. With the plastic, you're better off being too hot than too cold. Because if you're too cold, then you could cause issues with the temperature, being that the motor will lock up. And if the motor locks up for too long, you could actually start to destroy electronics. So that's not good. So as you see right now, definitely very hot compared to what I was dealing with at first. So what you guys see here on the bottom, which this thing is freaking hot. It's still hot. That's how long it stays hot. Let me just go ahead and like just rip off some of this, I guess. Show you guys. Okay. So here is what we looked at the beginning. So we want nice big curves. So what I'm going to do here on this one is I'm just going to run it until it starts to get rid of some of the heat. I'm back down to 240. I was at like 246 or something like that. So let me go ahead and, yeah, just let it fall. Okay. So this is around the diameter that you want usually. What you're getting right now is something like this, or it's just a mess like this. That's more of the extremes profile. The extreme profile is very quick at extruding, but it's not very accurate as far. Well, it's not. You can't take this apart. It's just like a solid mess. It's almost like 3D printing an object. It's just a solid mess at that point. What you want for the standard die, which most of you guys have for the Kickstarter, is you want these nice big loops. So this outside loop is starting to get a little too big. You want about 2.5 inch diameter loops, while these are about an inch or so loop, which is an inch diameter loop, which is way too small for the standard die. For the standard die, you want anywhere between 2 inch and 2.5 inch. So you want the loop to be about as big as the from bolt to bolt here, which you see from this other extrusion that I have. So you want it to be from about bolt to bolt, as you see there. So anywhere between here and here, or all the way touching the bolt, is fine. So if you have something like this where it's too hot, drop it down a few degrees, wait for it to extrude out, or you could, if you want to save material, go ahead and turn it off and just let it extrude out. As you see now, it's starting to cool down. And then it'll start to become, you know, bigger loops. So this is the ideal what you want to start with as far as when you first start extruding, because it's too hot. So too hot's way easier to work with than too cold, because you could easily, you know, just keep increasing the temperature until you get all the issues out. So Another thing that you can tell when you're doing too cold, so when you're doing too cold, it will extrude, but you'll have some weird looking filament. Basically what it'll come out is it'll come out like a, kind of like an opaque, very, very slowly, and it will be opaque, not transparent, and it will be very brittle when it cools down. Here's a longer piece. And it's be very lumpy, you know, very like jagged and rough as far as the texture is concerned. Not very symmetrical, and it holds a lot of the kinks. Reason being is that if it's cold, it doesn't work the kinks out. It doesn't stretch. So when it's hot, it stretches most of the kinks out. So now I can see it's starting to sort of cool down. So let me go ahead and throw away some of this other stuff. And then before the end of the video, I want to definitely get you some good extrusion here. So we want to have extrusion like this guy that we did right there at the beginning of the video. And again, like I was saying, the reason why I'm having such difficulty is because of the digital amp, which I'm soon, probably today, going to change it back to turn it to analog from digital to analog. So we want something like this, a nice coil like this, goes in from bolt to bolt. As you see now, we're getting colder and colder, starting to actually get to what we want here. Get rid of that wackety. Still doing some weird stuff. It might even rip right now because it's still a little hot. No, don't rip, don't rip, don't rip. Okay, so you see that we're starting to get the big coils. So we're gonna wrap this up pretty quick here once I get a nice perfect coil. So again, what you want to do, turn the extruder on, go 10 degrees Celsius above what you would normally print it as. Fill up the hopper to right as it starts to taper, right as the auger starts to taper into the shaft. Fill it up to that point, or up to the top of the 2-inch nipple. And then wait 10 minutes to allow the, well, you would wait 10 minutes until it gets to your target temp. The first time it gets to your target temp, go ahead and, you know, start the 10-minute mark. And then after the 10-minute mark, go back to the home page, turn on the extrusion motor. If it locks up, stop immediately, turn the extruder motor off, bump it up 2 degrees, then turn it back on, wait 3 minutes, then turn it back on again. If it doesn't work, if it locks up again, if the motor freezes, you know, it's basically not moving, you know, opposite of what it's doing now. You're going to bump it up 2 degrees, wait another 3 minutes, and then keep doing that until you can get it to be either too hot or right on this right point. If it comes out too hot like it is here, bump it down 2 degrees, wait, you know, extrude it out for 2 minutes, you know, to take some of the heat away, or just turn the motor off and wait 2 minutes or 3 minutes, and then go ahead and start again. And then keep going until you get extrusion just like this. So this is starting to get a little slow, actually. So when I was extruding it, I got rid of most of the heat. But this is as big of a loop as you probably want to get. So this is pretty much what you're shooting for. And then to make sure before you start extruding that you have the right temp, go ahead and push a piece of extrusion up to the nozzle, and then see if it starts to kind of like, once it starts to melt, and it should be melting very quickly when you push it with quite a bit of force. And yeah, so with this guy, you can either use it with or without a cooling fan, depending. But as you see here, I'm using without a cooling fan, and it should be able to separate pretty nicely. And then after you do that coarse calibration between it being too hot and too cold, and you get to this point, at this point it's the fine calibration, and you're going to base the fine calibration all on the diameter of the circle. If the diameter of the circle starts to get too big or too small, then you want to react accordingly. In this case, it's starting to get too big, so I would want to increase the temperature. If it gets too small, if it starts to tighten up, drop the temperature and just let it keep extruding, and it will start to, you know, drop it about 1 degree or so, and it'll start to come back out. And then wait, drop it 1 degree, wait a minute or 2 minutes, and let it keep extruding. If it's still tightening up, drop it an air degree, wait 2 minutes, and then it should start to tighten up to the point where you should get perfect extrusion. As you see here, it's starting to. Okay, I should be okay. So another thing is that when it starts to bend a little bit over to the cold side, it'll actually not be fast enough to hit the table before. So what it'll actually do is it'll start to create like a spring. It'll start to go up and it'll start to solidify. But as you see here, I'm brushing close on to it being too cold. So 244, 245 seems to be about the right temperature. Of course, it's a lot better if this was a analog instead of a digital, but this is what you're looking for. Alright, so that is the main points that I want to go over on this video. Please let me know of your experiences with your machine and any questions. If you are not a Kickstarter backer, go ahead and check out my website for more info on how you can pick up the machine. And I will see you guys in later videos. So again, the most important part, do not let your motor lock up. You will blow the electronic speed controller. So look up the manufacturer's suggested temp and add 10 degrees to that, wait 10 minutes, start your extrusion, and that should be pretty much good for you. And at that point, hopefully it's too hot or too cold. Too hot's a little easier to work with. And then you could just do fine calibration from there. Another thing is, as you see me doing with my finger, I'm guiding it to where it's doing its spirals. So that initial spiral is the most important spiral. So just go ahead and push that towards the leg. Push the wire towards the leg, and it'll do a nice spiral for you guys. Alright, so this is what you're looking to do here. About 2.5 inches, 2 3/4 inches, something like that. And that will give you great filament that's easy to separate, even without the cooling fan. Because if I had the cooling fan at this speed, it would definitely ruin the print. Alright, so thank you guys for watching, and I'll see you guys in a later video. And thanks for your interest in the Multistruder and the project. Thanks for watching. Take it easy. Catch you guys later. This has been Steven from the Green Engineers. Have a good day.